The use of thin layers of materials is a crucial need in many industries. Architectural glass, displays, and touch panels or solar cells all contain thin films. The most important coating process to produce these layers is called sputter deposition. How does it work? Sputtering deposition is done in a vacuum chamber. The most common substrate for the thin layers is glass. The sputter system can have different sizes depending on the application. The source of the thin film material is a planar or rotary sputtering target of metal, ceramic, or even plastic. Molybdenum targets, for example, are used to produce conductive thin films in displays or thin film solar cells. At this point, the process starts. Air is continuously removed by vacuum pumps. The base pressure in the vacuum is around 10 to the minus 6 millibar, which equals about a billionth of the atmospheric pressure. Argon gas is introduced continuously to achieve a low-pressure argon atmosphere. A magnet array inside the cylindrical target generates a magnetic field. The target is filled with cooling water, which will dissipate the heat generated during the sputtering process. The targets are rotating so that the material will be utilized uniformly. A high voltage is applied to the molybdenum target and creates a plasma, which is concentrated along the magnetic field. The plasma consists of argon atoms, positively charged argon ions, and free electrons. The positively charged argon ions are continuously generated by electrons hitting the argon atoms. The sputtering target is negatively charged. Therefore, the argon ions are attracted towards its surface. Let's see what happens. The argon ions collide with the target and eject molybdenum atoms from its surface. This is what the sputtering process is all about. In a way, it resembles a game of billiards, don't you think? Layer by layer, the ejected molybdenum atoms are deposited onto the glass substrate opposite the sputtering target. But let's go back to the target material. No metal can be made 100% pure. Iron or chromium impurities in molybdenum targets are critical. Why is that? Argon ions don't distinguish between molybdenum and impurities. Impurities will also be sputtered and incorporated into the thin film. Nobody wants that. Impurities can negatively influence the thin film properties, the electrical conductivity, for example. Only highly pure sputtering targets can ensure high-quality thin films.